This question says, aqueous hydrobromic acid reacts with solid sodium hydroxide to produce aqueous sodium bromide and liquid water. If 6.66 grams of water is produced from the reaction of 43.3 grams of hydrobromic acid and 16.8 grams of sodium hydroxide, calculate the percentage yield of water. So in this case, basically, we're doing a similar stoichiometry problem that we've done in our previous examples, and you can find those on the same playlist as you'll find this particular video. So if you'd like to see how to go through all of this part of the experiment, of the question, I would suggest to take a look at the previous videos. However, here I've already done the math to find the limiting reagent. So we started with the balanced chemical equation. All stoichiometry starts with a balanced chemical equation. We got our plan of attack to figure out how much water we could make if we used all of our hydrobromic acid. And we found out we could get this number, which I rounded to 3 significant figures because this is 3 significant figures. We found out how much water we could make if we used all of our 16.8 grams of sodium hydroxide using this plan of attack, and here I did the math out for that, and we found this number with 7.57 grams being with the correct number of significant figures. So we have already determined that if we use our 45.3 grams of hydrobromic acid, we'll make 10.1 grams of water, and if we use 16.8 grams of NaOH, we'll make 7.57 grams of water. This means that our theoretical yield is the 7.57 grams because this is less than this. So once we make 7.57 grams of water, we have no sodium hydroxide left because this is how much you can make if you use all 16.8 grams of sodium hydroxide. So if we have no sodium hydroxide left, we can't possibly make any more water. So this is our theoretical yield. But in this question, it asks us for the percent yield. So this is the new part, and that's the part that I want to go over for this question. So the percent yield is equal to the actual yield divided by the theoretical yield times 100. So when you actually do chemical reactions, you don't always get 100% of what you expect to get based on the amount of starting material. There may be side products, the reaction may not be 100% efficient. There are many reasons for this, but you don't always get exactly what you expect to get in the first place. So that leads us to a percentage yield calculation. Oftentimes, chemists want to have the highest percent yield possible in order to get the most product. On a question like this, or what you might find on a test, they'll usually give you a mass of a product that is produced, but in the lab, you'll actually weigh your product when you're done, and you'll calculate the percentage yield to see how efficient the reaction was. Anyway, to solve this problem, we're going to take the actual yield, which is 6.66 grams, the mass of water given in the problem, divide by the theoretical yield that we just found, and technically speaking, you should use all of the digits that the calculator gave you and not the rounded one. You should round at the end. So we're going to put in 7.5684 grams times 100. And when you do that math, I'm going to just shift this up a little bit and write it below, you get on the calculator 87.997,463 and some more numbers. So this is the percent. However, because this is 3 sig figs and this should be 3 sig figs, then you want to round to 3 sig figs. Since that's a 9, you want to round up, which makes this 88.0% as the percentage yield. Again, if you'd like a little bit more information about how to find the limiting reagent, the previous video on this playlist will help with that. But here I wanted to focus on finding the percentage yield.